Welcome back to another Explainer. Today, we're staging a bit of a historical heist. We're going to dig into the ancient mud, decode some absolutely brilliant archaeological math, and fundamentally rewrite the history of one of the most famous mathematical concepts of all time.
So what if the Pythagorean theorem wasn't actually discovered by Pythagoras? I know, right? It sounds like total mathematical heresy. It definitely creates a bit of cognitive dissonance right out of the gate. But today, we're putting on our historical detective hats and looking at the hard evidence that suggests the history books might just need a major rewrite.
Section 1. The math we all know. Okay, before we completely flip the script, let's just ground ourselves in the familiar. We all remember sitting in a grade school classroom, right? Sweating over this fundamental rule. In a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Or, as it's famously drummed into our heads, a squared plus b squared equals c squared. Now, traditionally, as the name obviously implies, this is attributed to the 6th century BCE Greek mathematician Pythagoras. It's literally an absolute cornerstone of Greek geometry. But, as we're about to see, the true origins of this theorem extend way further back.
Okay, let's dive into this. Section 2. The Ancient Indian Plot Twist.
If we look at the timeline, notice the massive gap here. Way over on the far left, we've got Baudhayana in India around 800 BCE. Then, skip ahead centuries later, and we see Pythagoras in Greece in the 6th century BCE, followed by Euclid in 300 BCE. The scholarly evidence from our source material shows that Baudhayana recorded this precise mathematical relationship centuries before Pythagoras was even born. Ancient Greek sources only even mention Pythagoras in relation to the theorem long after his death. The math was already alive and very well in India long before that.
Which brings us to Section 3, Geometry for the Gods.
So you might be wondering, why were they doing this level of math in 800 BCE? Well, it wasn't born in a theoretical vacuum. It didn't start with philosophers just sitting around pondering abstractions on a slate. No, it emerged directly from the dirt. It was driven by the highly practical, absolutely sacred necessity of Vedic altar construction. All of this was recorded in the Solba Sutras, which are these ancient Indian geometric handbooks. But I really want you to focus on the literal translation of that term. It translates to rules of the chord. That tells you everything about the incredibly tactile, physical nature of this ancient math. We're talking about mud and string geometry used to construct precise sacrificial altars for religious rituals.
Within these handbooks, we actually find this incredible, almost poetic quote from Baudhayana's Silva Sutra. The area covered by a rope stretched along the diagonal of a rectangle equals the combined area of its vertical and horizontal sides. It's just brilliant in its simplicity, isn't it? It captures incredibly complex spatial math just by talking about stretching everyday ropes.
And when we decode this for us today, Baudhayana's diagonal rope literally translates to our modern c squared, the hypotenuse. The vertical and horizontal sides represent our a squared and b squared. So those ancient words about stretching a cord across a rectangular altar, they are exactly perfectly our modern equation, a squared plus b squared equals c squared. Mind-blowing, right?
Section 4. Visualizing Ancient Mathematics.
Now, without modern algebraic symbols, how did they actually pull this off? Well, they used Pythagorean triples. These are specific sets of integers that satisfy the theorem perfectly. Baudhayana's text included lists of these, things like 3, 4, 5, 5, 12, 13, and 8, 15, 17. But don't just view these as numbers on a page. Think of them as an ancient architect's essential tool belt. By using ropes measured out to these exact proportions, they could guarantee perfect right angles, scale their altar dimensions precisely, and maintain the exact sacred geometric proportions required for their rituals. And they were doing all of this while working outside, in the mud.
And the wild part is, they understood visually exactly why this worked. Let's walk through this visual proof step by step. Step 1, you start with a large square. Step 2, you fit 4 identical, rotated right triangles inside the corners. Moving to step 3, you'll notice the empty, unshaded space right in the middle forms a square that is exactly c squared. Now for the real magic in step 4. If you just slide those exact same triangles around to form 2 rectangles, the remaining unshaded area transforms into 2 completely distinct squares. One is a squared and the other is b squared. Literally just by shifting shapes, the total empty space remains exactly the same, effortlessly proving that c squared must equal a squared plus b squared.
Now, what's really interesting about this slide is that this is both Baudhayana's actual geometrical demonstration. He wasn't just stating some abstract rule. He was actively demonstrating that the area of the square on the diagonal is geometrically equal to the sum of the areas of the squares on the other two sides. He was physically showing his work, visually, centuries ago.
Moving on to Section 5, Transforming Sacred Shapes. Because the sheer brilliance of the Pseudo-Sutras went far beyond simple right angles, we are talking about complex mathematical shape-shifting here. Vedic architects actually used these rules to combine two completely different, unequal squares into a single, brand new square. By marking specific intersecting points and drawing a new diagonal line, they could merge the shapes without losing a single fraction of the total combined area. It's like a giant, perfect geometric puzzle.
And this brilliantly illustrates an even more mind-bending feat. They can mathematically convert a square altar into a circular one. Yeah, circling the square. By drawing an arc and calculating specific intersecting points to find a new radius, they could create a circle that maintained the exact same sacred area as the original square. This level of area-preserving transformation was absolutely critical, because absolute precision in the altar's footprint was simply mandatory for the proper religious observance. You couldn't just be close, it had to be exact.
Section 6. A Tale of Two Cultures. Looking at the broader history of mathematics here, we see two very distinct, historically vital traditions. On the left, we have the Greek tradition. Think Pythagoras and later Euclid. Their approach was highly theoretical, focusing heavily on abstraction and rigorous formal deductive proofs. Then on the right, we have the ancient Indian tradition. This was intensely practical and intuition-driven. It was visual rope geometry utilized directly, on the ground, for Vedic altar construction. And the point here is that neither is better than the other. Rather, they validate the sheer brilliance of humanity, approaching the exact same universal truths from two completely different angles, one through formal logic and the other through incredible practical utility. So, the crucial point to take away from this explainer today is really a historical one. Mathematical discovery isn't always just a straight line belonging to a single culture. I want to leave you with this question to ponder on our final slide. If mathematical truths exist everywhere, whose genius is more profound? The one written as a formal theory on a slate, or the one practically carved into the earth with a rope? Thank you so much for joining me to explore the Pseudo-Sutras today. Keep questioning, keep learning, and I'll catch you in the next explainer.